Ever since it was demoted from its planetary status, Pluto has been a source of fascination and debate. But what if I told you that this distant, icy world is far more bizarre and mysterious than we ever imagined? For decades, Pluto was just a faint, blurry dot in our most powerful telescopes. We knew it was small, cold, and incredibly far away, but its true nature remained a mystery. That all changed in 2015. NASA's New Horizons spacecraft executed a daring flyby of Pluto, giving humanity its first ever close-up look. The images it sent back were nothing short of breathtaking. This wasn't just a dead, frozen rock. Pluto was alive in a geological sense. We saw vast plains of frozen nitrogen, some of the youngest surfaces in the solar system, suggesting ongoing geological activity. Towering mountains made of water ice, as tall as the Rockies on Earth, scraped the sky. And perhaps most poetically, a thin, delicate atmosphere with layers of a faint bluish haze surrounded this dwarf planet, giving it an ethereal glow. The New Horizons mission answered many questions, but it also opened up a Pandora's box of new ones. One of the biggest puzzles was Pluto's atmosphere. Based on what we knew about its composition, mostly nitrogen, with traces of methane and carbon monoxide, scientists had models predicting its temperature. But the data from New Horizons was baffling. The atmosphere was bone-chillingly cold, far colder than any of our models could explain. At about minus 330 degrees Fahrenheit, or minus 200 degrees Celsius, it was a full 50 degrees Fahrenheit colder than expected. Something was actively cooling Pluto's upper atmosphere, but what? This single anomaly sent researchers scrambling. It was a classic scientific mystery. The data was clear, but the explanation was missing. It meant our understanding of how atmospheres work in such extreme, cold environments was fundamentally incomplete. For years, scientists at NASA and other institutions pored over the gigabytes of data sent back by New Horizons, running simulations, testing hypotheses, and trying to crack the code of Pluto's atmospheric refrigerator. What could possibly be sucking so much heat out of the sky? Several theories were proposed. Could it be an unknown chemical process? Was there some interaction with the solar wind that we hadn't accounted for? The answer, when it finally began to emerge, was linked to one of Pluto's most beautiful features, its haze. In 2017, a groundbreaking study proposed a new theory. The haze wasn't just a pretty, uniform fog. Instead, it was made of solid hydrocarbon particles, soot-like grains formed high in the atmosphere when ultraviolet sunlight breaks down methane gas. These tiny particles, instead of warming the atmosphere by absorbing heat, were doing the exact opposite. They were radiating heat back out into space, acting like millions of microscopic air conditioners, efficiently cooling the upper atmosphere. This was a completely unexpected mechanism. On planets like Earth, aerosols in the atmosphere typically trap heat, contributing to warming. Pluto was playing by a different set of rules. But here's where the James Webb Space Telescope comes into the picture, even though its name is in the title. The groundwork for understanding these atmospheric processes was laid by missions like New Horizons. Webb, with its incredible infrared capabilities, is perfectly suited to study these kinds of cold, distant atmospheres in unprecedented detail. While New Horizons gave us a snapshot, Webb can monitor Pluto over time. It can analyze the chemical composition of that haze with a precision we've never had before. It can measure the temperature at different altitudes, confirming or refining the cooling theory. The name James Webb in our exploration isn't just about a single observation. It represents the next generation of tools we're using to solve the mysteries uncovered by its predecessors. Webb's observations of other Kuiper Belt objects, and even Pluto itself, will help us understand if this atmospheric cooling is a unique feature of Pluto or a common process for icy worlds on the edge of our solar system. This haze is what gives Pluto its distinct bluish tint. Similar to how particles in Earth's atmosphere scatter sunlight to make our sky blue, the tiny soot particles in Pluto's atmosphere do the same, but the chemistry is entirely different. It's a product of high-altitude processes, driven by the faint but persistent sunlight that reaches that far-flung corner of the solar system. These haze particles eventually settle down onto the surface, creating some of the dark reddish patches seen on Pluto's equator. They are literally the building blocks of Pluto's surface features, raining down from the sky over millions of years. So Pluto is not just a simple ball of ice and rock. It's a dynamic world with a complex climate system that challenges our understanding of planetary science. It has nitrogen glaciers that flow like ice on Earth, a vast, heart-shaped plain that might be hiding a subsurface ocean, and an atmosphere that actively cools itself in a way we've never seen before. Each discovery seems to peel back one layer of mystery only to reveal another, even stranger one underneath. The story of Pluto is a powerful reminder that our solar system is filled with wonders that we are only just beginning to understand. From a demoted planet to a scientific superstar, Pluto continues to captivate and surprise us. The data from New Horizons, combined with the future potential of telescopes like James Webb, ensures that this strange and beautiful world will keep its secrets and our attention for many years to come. Thank you so much for joining me on this journey to the edge of our solar system. What do you find most fascinating about Pluto? Let me know in the comments below. And if you enjoyed this deep dive, don't forget to hit that like button and subscribe for more explorations into the mysteries of our universe. We'll see you in the next video.